Hello, this is the stage 3 of the project Next Stop Recommendation System. This project was part of the MyTax Global Internship 2021. So in stage 3, we'll be seeing two algorithms which are used for the recommendations. The first one is the collaborative filter and recommendation algorithm. Collaborative filtering is nothing but the recommendation algorithm is going to consider all the routes traveled by all the users, and it's going to see how similar is your route to the other user's route, and it's going to use that for its recommendation. There's another recommendation algorithm that we'll be seeing that's based on categories, and it's based on only your past history of categories that you've traveled, and it's going to be using the regular expression base. So now first let's look at the collaborative filtering. So here this is a collab which is created, and you can the code is already written here in Python. So let me explain it through the Python code. So first is the route list. So here the route list means that it's the route that's traveled by all the users. So let's say that the first user traveled J, G, C, A, E nodes in the sequence, and then the second user has traveled H, G, A, D, E in the sequence, and so on. So and now that there's another user, let's say Michael, and Michael has traveled the route JGCA, and then now Michael is trying to get recommendation from the next stop recommendation, and we'll see what recommendation is going to get. So first, before all, now when Michael clicks on get recommendation, he's going to be getting some recommendations. So before getting the recommendation, whenever a user is traveling to a new place and that place is being identified as added to the database, that the server is actually automatically going to calculate something called GSP. So what it does is it's going to find out all the frequent routes traveled by all the users of the app. So what frequent routes are the only routes that has to be considered for recommendation algorithms. The other routes are not going to be considered because they are not frequent enough to be considered by recommendation algorithm. Frequent meaning something that's used again and again. So we set the preset support, and using the preset support is when we try to get our frequent routes. So now the frequent routes can also have nodes skipped in between. So let's say that JGCAE. So JC also could be a frequent route, but then JC should also be repeated in all the other routes. So that's how it works. So once we get our frequent routes, we're going to use we are going to start with the recommendation routes. So all the frequent routes, you're going to leave one behind. So let's say AC was our frequent route. So the recommendation rule will become like A is recommending C. Or so whenever the you can also say that whenever the users traveled A, you can recommend the route C. Whenever the users traveled A, you can also recommend them he. Or whenever the user travels BA in sequence, you can recommend the route C. So that's how this recommendation rule works. And once you have the recommendation rules, now let's say that you just have 8 records in the recommendation rules. But let's say that when users keep traveling all around, you will have hundreds and thousands of rules, and it's very difficult to keep track of each rule and to compare it. So we need to have something called cursor, which can keep track of all the recommendations and the recommendations that we require. So basically the goal from this is we need to select, or we need to hand pick all those recommendations that can help us give recommendation. In our case, so in case Michael wants to get some recommendation, this recommendation rule is going to be hand picked, and we are going to select all these recommendation rules which are going to be useful for Michael to get his next stop recommendations. So how is that going to happen? So we're going to have something called cursor. So what a cursor does is, a cursor is actually going to keep note of the index of that. Let's say now Michael has traveled JGCA. So what it does is, the cursor is not going to consider the last element, but from the first element to the last but one element. So here in this case it is going to be JGC, and A is going to be left out. I'll tell you why A is going to be left out. So JGC, it's going to go in a loop, and it's going to see if J is found in anywhere in the left hand side of the recommendation rules. J is not found anywhere, so it's going to skip it. Next, it's going to see G. It sees that G is here, G is here, and G is here, and it's going to keep note of its position. So the index of this is 1, index of this is 1, index of this is 1. JG. Next is C, and it sees that C is not here anywhere, and it's going to skip. So that is its cursor position initially. So JGC is 1, 1, and 1, and everything else is 0. And then for the final position, JGCA, whenever the user reaches the last position, A, it's going to see its position. So the position of A, it's there here, it's there here, it's there here, and here. So for that a position A, its position is going to be noted. And since it's the last element, you're also going to have a minus element here. So that minus element is going to make sure to tell the user that, yeah, the user is in the last position in the recommendation rule, LHS rule. So that's why we have that. And then once we take, so this is the cursor position before A, and this is the cursor position after A is reached. And based on this, it's going to see if you subtract this minus this, and if you're getting 1 as your answer, all those rules is going to be considered for your recommendation rules. So here 2 minus 1 rule number 8, 1 minus 0 rule number 2, 1 minus 0 rule number 1 is going to be the potential recommendation rules. And now since we got, okay, so these are your potential recommendation rules, we need a way to actually a way to actually measure if that recommendation rule is good and the recommendation rule is bad. So how are we going to do that? This is the most straightforward way is actually to find the similarity. Similarity is very simple. It's going to see the length of the recommendation left hand side, and it's going to see the length of the actual route. So our actual route is JGCA, which is 4, and it's here it's going to see 1, 1, 2. Basically, more longer your recommendation, so it's basically telling more longer your recommendation rule is, more similar it is and more better it's going to be recommended. But this won't work all the time, because the length might be the same for most of the cases, and let's say that you have 3 recommendations, all of them have the same similarity. Again, it's going to be difficult for you to rank which is a better recommendation, and that's why this is more of a foreground approach. It's not something that is going to be used. The thing that's going to be used is confidence. So how this confidence and strength works is, it's going to see the support of this, the left hand side of the rule, and it's going to see the support of the whole rule. So left hand side plus right hand side. So your left hand support is 1, your right hand support is 0.4. Now it's going to divide rule support, the whole rule support divided by the left hand support, which is going to give you confidence, and confidence multiplied by the rule support is going to give you the strength. The strength is actually a very good metric for you to like recommend rules. It's basically here in your similarity, it's not considering the transaction table or the route list into consideration. It's just telling based on the route length. Bigger the recommendation rule, better the similarities. But here you're actually considering the route list into consideration. You're going to see how frequent is the left hand side, how frequent is the whole rule, and based on that, it's trying to give a confidence and a strength value. And then finally, you have something called bias similarity. So we have we have something called strength, we have something called similarity, which was found from the previous thing, and now we are going to find out a way to actually get both of these two worlds together. So you have something called bias similarity. A bias similarity is value between 0 to 1, and it's going to tell how biased are you to similarity than to strength. And then finally you're going to multiply bias similarity with similarity, and 1 minus bias similarity with the strength, and when you add both, you're going to get the recommendability. This recommendability is a very good measure on the recommendation rules, and here it's actually telling me that after JGCA, you have to recommend the node E, and which is a very good recommendation according to the algorithm. Now this was based on the collaborative, like I told. There's another kind of recommendation which is based on just the user's point of view. It's not going to see the other user's point of view. It's only seeing your interest. So what is it? How is it actually working? So let's say that you are traveling. First you're going to a bank, and after that to a hotel, and this pattern is repeated again. So again to a bank, again to a hotel. So now once you go to a bank again and you click on get recommendation, obvious way for me to tell you to recommend is another hotel. So that's how it works. So your regular expression is kind of telling you the pattern. It's going to generalize a pattern and it's going to tell you the next best route. It's not going to see other users category list. It's just going to see your category list, and it's going to see how is a general pattern there and how to recommend the next recommendation. Okay, so for example, let's say that our category list is going to be 4 A's followed by 3 B's followed by 2 C's followed by 2 D's and then A, B, C, D again. So now, if you find just the unique elements out of it, it's just A, B, C, D, A, B, C, D. And then if you just try to make it into a regular expression, you're just going to see A plus B plus C plus D plus the whole plus. So now once after D, what is the best thing for me to recommend you? The best thing for me to recommend is A again. So I think that's what's going to be recommended again. So it can either be D repeated. So yeah. So now since D was repeated in the past, so here D was repeated in the past, I can recommend D again, or I can recommend you A. So we have J, 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 A, J. So now your unique list is obviously going to be J, A, J, and then J is repeated 5 times, A is repeated 4 times, again J is repeated 5 times. And then if you find out its actual regular expression, it's going to be J plus A star the whole plus. Because J is repeated 1 or more times, but then A is repeated 0 or more times, because the second time it's only finding J, it's not finding A. So J plus A star the whole plus. So now if you ask me what's the best thing to recommend, A is it's going to recommend me again J and A again. So that's how it works. So it's either A or J, because A can be repeated once more. A can also be recommended, or it can start over again and start from J again. So J can also be recommended. So this is how the regular expression based algorithm is working. But then if you see here, the categories are not going to be a single letter, or even the point of interest cannot be a single letter. It's going to be a hash value. So hash value is going to be just like this, and then you're going to get a hash value, and that hash value is going to be given to the phone, and the phone is actually going to decode that hash value because it already has the category and its equivalent hash value. So it's going to see from that, it's going to map that hash value to a value, and it's going to be shown to the user, and that's how it's going to be done. So yeah, this is about the stage 3 of the implementation.